Alright guys, as promised, I told you I would make a video that goes over the formula, okay, for how to find the centroid algebraically, which really simplifies things. Okay, so to find the x-coordinate, what you're going to do is you're going to take your first x plus your second x plus your third x and divide by 3. So essentially you're averaging all the x's. And then to find the y-coordinate, you're going to take your first y plus your second y plus your third y and divide it all by 3. So again, you're averaging your x's and you're averaging your y's. So let's take a look at example number 1. Okay, my first x, second x, third x, 1 plus negative 3 plus negative 1 divided by 3. It's going to give me negative 3 over 3, which is negative 1. For my y-coordinate, y, and y, 0 plus 2 plus 7 divided by 3. So that's going to be 9 on top, 3 on bottom, for a final answer of 3. Okay, that means that the centroid of this triangle is negative 1, 3. And that is the final answer. Go ahead and pause this video and complete examples 2 and 3 on your own, and then play the video to ensure that you have the correct answer. So, for example 2, you should have gotten 5/3, 2/3. And for example 3, you should have gotten 4, 2. Hopefully you feel a lot more comfortable, okay, with finding the centroid of a triangle algebraically. Now let's go over a few more examples, finding the orthocenter graphically. Remember, the orthocenter is made up of perpendicular bisectors. Oh wait, sorry, not perpendicular bisectors, my bad, of altitudes. Okay, remember altitudes go from vertex to the opposite side perpendicularly. Okay, sometimes the altitudes are inside the triangle, sometimes the altitudes are outside of the triangle, and sometimes the altitudes are on the triangle. That has to do with whether it's acute, obtuse, or right. So, let's just think off to the side for a second. If the triangle is acute, then the altitude is going to fall inside. If the triangle is obtuse, then the altitude is going to fall outside. And if the triangle is right, then the altitude is essentially this leg of the triangle itself. So let's apply this understanding to the first example. So in this first example, notice this is obtuse. So one altitude that's going to be quite simple to find is going to be the altitude that drops to this horizontal base. So from x, okay, I can drop that altitude in right here. Okay, then we only have to find one additional altitude. I'm going to find the altitude going through point Y, which is at 2, -3, and it's going to be perpendicular to xz. Well, in order for it to be perpendicular to xz, I need to know the slope of xz. So, the slope of xz, it appears as though you go up 1, 2, 3, 4, 5, 6, 7. Okay, and back 1, 2, 3. Okay, so a slope with the opposite reciprocal would be +3 over 7. So what I'm going to do is I'm going to start at point Y, and I'm going to build this slope off of point Y. So up 3, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7. Down 3, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7. Okay, and let's go down 3 again. 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7. And we can connect these points. I'm going to extend my initial altitude out further to find that point of intersection, which is at, let's see, -7, -7. Now I would like for you to pause this video, try and repeat this process with example 2 and example 3. Good luck. So let's take a look at example 2. This altitude is going to be quite simple to find, okay, because it's just going to drop perpendicular to this horizontal base right here. Okay, then I'm going to find the altitude going from point X, which is at -6, 2, perpendicular to line XZ. So first I'm going to need to know the slope of XZ. And it appears as though to get from from YZ. The slope to get from Y to Z, you go up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6. So our opposite reciprocal slope is going to be -1. So we're going to start at point X, go down 1, over 1, down 1, over 1, down 1, over, and we'll continue until we find the point of intersection. Notice that if we were to extend this line, this is where it is perpendicular, okay, to the opposite side extended out. So it appears as though our orthocenter for the second example is at 6, -10. The last example is relatively easy because this is a right triangle. So here is one altitude, here is another altitude. Therefore, in this example, the orthocenter is at 0, 0. Let's now take a look at how to find the circumcenter graphically and algebraically, so a combination of the both. Remember, the circumcenter is comprised of the perpendicular bisectors. Okay, so looking at this example, anytime I'm offered a horizontal or vertical line, I like to start there. I think those are the easiest place to start. If it's going to be bisecting, I need to find the midpoint. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. Okay, so there's 5 units on this side, 5 units on this side. And if it's going to be perpendicular to horizontal, that would just be vertical. Okay, next, I'm going to have to find the midpoint of either XY or XZ. It doesn't matter which. I'm going to find the midpoint of XY. So Y is at 8, 0. X is at 0, 4. So the midpoint is going to be 8 over 2, which is 4. 4 over 2, which is 2. So 4, 2. That's breaking it in the middle. Now, if it's going to be perpendicular to XY, then I need to know the slope of XY. So let's go ahead and find that now. Y minus Y, so 4 minus 0 over X minus X, 0 minus 8. That's 4 over -8, which is -1/2. Right, so I'm going to build off of this midpoint at the opposite reciprocal. Well, the opposite reciprocal would be positive 2 over 1. Right, so I'm going to go up 2 over 1, up 2 over 1, and I can go in the other direction, down 2, back 1, down 2, back 1, down 2, back 1. And if you notice, okay, these intersect at 3, 0. So our circumcenter is 3, 0 in this example. Go ahead and pause the video and see if you can find the circumcenter for example 2 and example 3. So, as I said, it's always easiest to start with a piece that's horizontal or vertical. It appears as though the midpoint's right here, putting 3 units on this side, 3 units on that side. If it's going to be perpendicular to vertical, that would have to be horizontal. Okay, next, it doesn't matter whether I find the midpoint of YZ or XY. I'm going to find the midpoint of YZ. So my Z coordinate is 8, 8. and my y coordinate is 4, 6. So the midpoint is going to be 8 plus 4 divided by 2, and 6 plus 8 divided by 2. So it appears the midpoint is 6, 7. Now I need to know the slope of yz, okay, to find the opposite reciprocal. Okay, so the slope of yz, y minus y over x minus x, appears to be 2 over 4, which is 1/2, right? And the opposite reciprocal of 1/2 is negative 2 over 1. So I'm going to start at the midpoint and build the opposite reciprocal off of this. So down 2 over 1, down 2 over 1, so on and so forth. Right, so it appears as though the circumcenter in this example is 7, 5. In the very last example, okay, finding the midpoint of this horizontal piece and making it perpendicular. Finding the midpoint of this vertical piece, 1, 2, 3, 4, 1, 2, 3, 4. And finding this horizontal piece, or the perpendicular to a vertical. Therefore, the circumcenter is located at 3, 4. And that concludes our review today. Now go ahead and move on to the optional 5-6 worksheet. You can work through the bell and check your answers with the answer key on CTLS. Thanks.